Micrometer screw gauge is a device used to measure lengths that are very small. Lengths such as the diameters of thin wires used in the lab that cannot be measured by vernier calipers. A micrometer screw gauge consists of a U-shaped frame The U-shaped frame carries the spindle and the anvil. The spindle is connected to the thimble, which carries a rotating scale. So we have the anvil, the spindle, which is connected to the thimble. The thimble has a rotating scale so that when the thimble is rotated, the scale rotates in a given direction as the spindle moves back and forth. We also have the sleeve, which has a linear scale in millimeters. The thimble has a circular scale with 50 divisions. Whereby each division is equals to 0.5 millimeters divided by 50, which is 0.01 millimeters. So a single division is equivalent to a length of 0.01 millimeters. We have the ratchet. The ratchet prevents the user from exerting unnecessary pressure on the object being measured, whose length is being measured. We have 1 millimeter divisions and half divisions on the sleeve scale. Taking readings. Using a micrometer screw gauge. We have two scales. We have the sleeve scale and the thimble scale, both of which gives readings that are recorded, added together to give the reading of a given length. So we will abbreviate the sleeve scale as MSR, which means main scale reading. So as stated earlier, the sleeve has 1 millimeter and half millimeter divisions, whereas the thimble scale has either 100 divisions or 50 divisions, depending on the type of micrometer screw gauge we are using. These divisions are such that each division has a length equal to 0.01 millimeters. So in taking readings, we take the main scale reading. We also get the number of divisions corresponding to the 0 mark of the main scale, then multiply by 0.01 millimeters. We add the two readings to get a reading representing a given length. Just like the vernier calipers, the micrometer screw gauge has a zero error. Zero error results from non-coincidence of the two scales. In a normal vernier calipers, without any zero error, we always expect the zero mark of the thimble scale to coincide with the zero mark of the main scale. When the two do not coincide before taking any measurements, then we say that there is a zero error. It can happen in two ways. So it can happen so that the zero mark of the thimble scale is below that of the main scale. In such cases, we have the positive zero error. Also, it can happen so that the zero mark on the thimble scale is above the zero mark of the sleeve scale, and in such cases we have the negative zero error. When the two zeros, both of the thimble scale and of the sleeve scale, are in coincidence, we say that there is no zero error. So we have two types of zero errors: positive zero error and negative zero error, that have been explained here in